I want you to find a mirror, any mirror, the one in your bathroom, the one on your phone camera, the one in your car. Look at it. Look at what you think is your face. What you are seeing is not you. It has never been you. And the reason it is not you is not a trick of language or a philosophical sleight of hand. It is physics. Deep, precise, disturbing physics that starts with the simplest question you could ask about a mirror and ends somewhere that will make you question what seeing actually means. Most people, when they think about what a mirror does wrong, think about the left-right flip. You raise your right hand, the reflection raises its left. You part your hair on the left, the reflection parts on the right. And the standard explanation is that mirrors reverse left and right, but not up and down, and this feels slightly unsatisfying, but people accept it and move on. But that explanation is wrong, not incomplete, wrong. I have spent my career finding the hidden structure underneath apparent complexity, finding the single principle that explains the many effects, and mirrors kept presenting themselves to me as one of the most deceptive objects in ordinary life, not because they distort, because they do not distort in the way everyone thinks. The mirror is not doing what you think it is doing, and once you understand what it is actually doing, you will realize that the problem is not in the mirror at all. The problem is in you, in how your brain constructs what it calls seeing. I am going to tell you what a mirror actually does, what light actually does when it hits a reflective surface, what your brain does with the result, and what all of that reveals about the nature of perception, the limits of what we call observation, and the deeply strange relationship between the physical world and the experience of it. Let us start with the left-right question, because it is the right place to start, even though the standard answer is wrong. Stand in front of a mirror. You face north. Your reflection also faces north, toward you. Your right hand is on the east side of your body. Your reflection's right hand is also on the east side of its body. The mirror has not moved your right hand to the left. Your right hand and your reflection's right hand are on the same side of the room. East, always east. So what has the mirror actually reversed? Front and back. Only front and back. You face north. Your reflection faces south. The mirror has taken the direction you were pointing, north, and flipped it to south. It has reflected you through the plane of the mirror, which runs east-west. Everything that was in front of you is now behind your reflection. Everything behind you is now in front of your reflection. Front and back reversed. Left and right untouched. Up and down untouched. So why does it look like left and right are reversed? Why does your reflection appear to be your mirror image rather than simply you facing the other direction? Because you are mentally rotating. When you imagine turning around to face the direction your reflection is facing, when you imagine walking through the mirror and turning to look back at yourself, you instinctively rotate around the vertical axis. You spin left or right. And when you do that spin in your imagination, left and right swap. But that swap is not the mirror doing something. That swap is you doing something. It is your brain performing an imaginary rotation and attributing the result to the mirror. If instead you imagine turning around by flipping over a horizontal axis, by doing a forward somersault, then when you face the direction your reflection faces, up and down would be swapped instead of left and right. The mirror would appear to reverse up and down. But you never imagine rotating that way when looking at a mirror because it feels unnatural. You almost always imagine spinning around the vertical axis. And so left and right appear reversed. But the mirror did not do that. You did. The mirror reverses nothing you call left or right. Your brain does. Every time. Without exception. Without your awareness. This is already disturbing, I think. The idea that something you have seen your entire life, something you have explained to yourself with a story about mirrors reversing left and right, is actually a story your brain is telling itself. The mirror is innocent. The confusion is entirely internal. But this is just the beginning, because we have not yet talked about what the mirror is actually doing physically. We have only talked about what your brain does with the result. Let me tell you what the mirror is actually doing. What is reflection? What actually happens when light hits a mirror? The naive picture is that light bounces off the mirror surface the way a ball bounces off a wall. The angle of incidence equals the angle of reflection. Light comes in at 30 degrees, bounces off at 30 degrees on the other side, clean, simple, mechanical. That picture is not wrong in its predictions. The angle of incidence does equal the angle of reflection, but it gives you no understanding of why. It describes the outcome without describing the mechanism. And the mechanism is one of the most extraordinary things in all of physics. Light is an electromagnetic wave. It is an oscillating electric and magnetic field propagating through space. When that wave hits the surface of a metal mirror, it encounters a sea of free electrons. Metals have electrons that are not bound to individual atoms but are free to move through the entire material. These are the electrons responsible for electrical conductivity. And when the oscillating electric field of the light wave hits them, it does exactly what you would expect an electric field to do to charged particles. It makes them oscillate. The electrons in the metal surface start vibrating in response to the incoming light wave. Millions of electrons, all oscillating together, driven by the electric field of the light. And here's the critical part. Oscillating charges radiate. This is one of the fundamental results of electromagnetism. Any accelerating charge emits electromagnetic radiation. The electrons in the mirror surface are accelerating. They are oscillating back and forth, and so they emit light, new light generated by the electrons themselves. The light you see in a mirror is not the original light bouncing back. It is new light, generated by the electrons in the metal, emitted in response to the original light. The original light is absorbed by the electrons. The electrons oscillate. The oscillating electrons emit new light. And the direction of that new light is determined by the geometry of the oscillation in the surface. The result, when you add up all the contributions from all the oscillating electrons across the entire surface, is light emerging at the reflection angle. The law of reflection, angle in equals angle out, is not a mechanical bouncing rule. It is the result of an enormous collective quantum mechanical process involving millions of electrons, all oscillating and radiating simultaneously. This is where we need to go deeper, because I just described the process in terms of classical oscillating electrons, and that description is useful but incomplete. The full picture requires quantum electrodynamics, QED, the quantum theory of how light and matter interact. And the QED picture of reflection is one of the most beautiful and disturbing things in all of physics. In quantum electrodynamics, light is not a wave in the classical sense. It is a stream of photons, individual quanta of electromagnetic energy. Each photon has a definite energy and a definite momentum. And when a photon encounters a mirror, what happens is not a simple bounce. What happens is something that has no classical analog at all. In QED, a photon traveling toward a mirror does not take a single definite path. It takes every possible path simultaneously, every path from the light source to every point on the mirror surface to your eye, every single one. The photon explores all of them at once. Each path has an associated probability amplitude, a complex number whose phase is related to the time the photon would take to travel that path. And the actual probability of the photon reaching your eye is calculated by adding up all these amplitudes from all these paths and squaring the result. Most of the paths cancel each other out. The amplitudes from paths that are slightly different from each other have slightly different phases, and when you add them up, they cancel. The contributions from paths far from the reflection angle cancel almost completely, but near the reflection angle, near the path where the angle of incidence equals the angle of reflection, the phases of nearby paths are nearly equal. They add constructively rather than canceling. The probability amplitude is large. The photon is overwhelmingly likely to arrive at the angle we call the reflection angle. The law of reflection is not a law about bouncing. It is a law about quantum mechanical probability amplitudes constructively interfering near one particular angle and destructively interfering everywhere else. The mirror works because quantum mechanics works. The reflection angle is not where the photon goes because it bounced there. It is where the photon goes because that is where the quantum mechanical probability is concentrated after every possible path has been accounted for. The photon, in a very real sense, sampled every part of the mirror before arriving at your eye. I want you to sit with that for a moment. Every time you look in a mirror, the photons reaching your eyes have, in the quantum mechanical sense, explored every point on the mirror surface. The mirror you see is not the result of light bouncing off one point. It is the result of quantum mechanical amplitudes from across the entire mirror surface combining to produce what you see. The image is a collective quantum phenomenon, not a reflection in the mechanical sense, a probability distribution that happens to look like a reflection. Now I want to talk about color, because most mirrors are not perfect reflectors, and the reason they are not is deeply connected to what we just discussed. A perfect mirror would reflect all wavelengths of light equally. Every color would bounce back with equal intensity. The image would be perfectly neutral. Real mirrors are not like that. A typical silver mirror reflects about 95% of visible light. An aluminum mirror reflects about 90%. Some wavelengths are reflected more efficiently than others. And this is why mirrors have a very slight color cast that most people have never noticed. Look at a mirror in a mirror. Place two mirrors facing each other and look at the infinite series of reflections. As you look deeper into the series, each image slightly darker than the last, you will notice something. The deeper reflections have a greenish tint. Silver mirrors reflect green light slightly more efficiently than red or blue. Each reflection passes through that slight color bias. After enough reflections, the bias accumulates and you can see it. The mirror has a color, a very subtle one, but real. And this color, this slight preferential reflection of certain wavelengths, comes directly from the quantum mechanical structure of the electrons in the metal. Different metals have different electronic structures, different energy levels, different resonances. The interaction between the incoming photons and the electrons depends on the energy of the photon relative to the electronic energy levels of the metal. Some photon energies couple more strongly to the electrons. They drive the electron oscillations more effectively. They are reflected more efficiently. The color of the mirror is a fingerprint of the quantum mechanical structure of the electrons in the metal. Gold reflects red and yellow light more strongly than blue, which is why gold looks gold. Copper reflects red more strongly than blue, which is why copper looks copper-colored. Silver reflects all visible wavelengths nearly equally, which is why silver looks silver, nearly colorless. The color of every metal you have ever seen is a direct consequence of its electronic band structure interacting with photons of different energies. When you look at a gold ring, you are seeing quantum mechanics. When you look in a silver mirror, you are seeing quantum mechanics. The colors of metals are not paint. They are electronic structure. Now, let me come back to the central question. Why does the mirror not show you what you look like? We have established that the left-right reversal is something your brain does, not the mirror. We have established that the light reaching your eyes from the mirror is not bounced light, but newly generated light from oscillating electrons. But there is a third and deeper reason the mirror does not show you what you look like. And this one has nothing to do with physics and everything to do with what you actually are. You have never seen your own face, not directly, not once in your entire life. Every other person you have ever met has seen your face directly. Light bouncing off your face, traveling straight to their eyes, no intermediary. But you have only ever seen your face through intermediaries, mirrors, photographs, video, all of them distortions of one kind or another. The mirror shows you a front-back reversed image. Photographs show you a frozen moment with the color distortions of whatever sensor or film captured the image. Video shows you yourself in motion, which is how others see you, but through a lens that distorts perspective. None of them are what other people see when they look at you. None of them are your face as it exists in the world. Your face, as experienced by other people, is something you have never seen and can never see. It is invisible to you by the geometry of your own existence. And this is where I think the physics and the philosophy converge in a way that I find genuinely unsettling, because the inability to see your own face directly is not a practical limitation we might overcome with better technology. It is a structural feature of being an observer embedded in the thing being observed. You cannot step outside yourself. You cannot see yourself from the position others occupy. Any instrument you use to look at yourself changes the geometry, creates an intermediary, introduces a transformation. Physicists encounter this problem in a different context. In quantum mechanics, the act of observation changes the system being observed. You cannot measure the position of a particle without disturbing its momentum. You cannot observe a quantum system without becoming part of it. The observer is never truly outside the observation. The mirror problem is a macroscopic, everyday version of the same fundamental issue. To observe yourself, you must insert an instrument. The instrument transforms what you see. You can never see the untransformed original. But I want to push even further, because even if you could somehow see your face without a mirror, even if you had eyes in the back of your head and could look at yourself directly, what you would see would still not be you as you exist right now. Light travels at 300 million meters per second. That is fast, incomprehensibly fast by any human standard, but it is not infinite. When you look at yourself in a mirror, the light leaves your face, travels to the mirror, reflects, and travels back to your eyes. This takes time, an extremely small amount of time. For a mirror 1 meter away, about 6 nanoseconds, 6 billionths of a second. You are seeing yourself 6 nanoseconds in the past. The face in the mirror is not your face as it is now. It is your face as it was when the light left it. For a bathroom mirror, this delay is negligible, but the principle is absolute. You are always looking at the past. Every mirror image, every photograph, every perception of any kind is a perception of how things were when the light left them, not how they are when the light arrives. You have never seen the present. No one has. All observation is observation of the past. The question is only how far back. When you look at the sun, you see it as it was 8 minutes ago. When you look at the nearest star, you see it as it was 4 years ago. When you look at the Andromeda galaxy, you see it as it was 2.5 million years ago. And when you look in the mirror, you see yourself as you were 6 nanoseconds ago. The delay varies by 38 orders of magnitude. The principle is the same. Light takes time. Observation is always retrospective. And I find this one of the most clarifying ideas in physics. The word observation implies immediacy. We say we observe something as if we are there, present, simultaneous with the thing we are watching. But we are not. We are always downstream, always receiving signals that departed their source in the past. The universe does not deliver information instantaneously. It delivers it at the speed of light, which means everything we call the present is actually a collage of different pasts, each at a different distance, each at a slightly different time. Now I want to go back to the quantum mechanics, because there is one more thing about mirrors that most people have never considered, and that I think is the most disturbing of all. When you look at your reflection in a mirror, you are seeing photons that were emitted by a light source, absorbed by your face, re-emitted by your skin, traveled to the mirror, absorbed by the electrons in the metal, re-emitted by those electrons, traveled to your eyes, been absorbed by the photoreceptors in your retina, triggered a cascade of electrochemical signals in your nervous system, and finally been interpreted by your visual cortex as an image of a face. Every step of that process is a quantum mechanical event. The absorption and emission of photons by your skin, the interaction with the mirror electrons, the triggering of the photoreceptors in your eye. Every single one of those events is governed by quantum electrodynamics, probability amplitudes, wave functions, superpositions that collapse into definite outcomes only when an interaction occurs. The photons that reach your eye from the mirror are not the same photons that left your face. They are not even the same photons that hit the mirror. They are new photons generated by the electrons in the mirror, whose properties are determined by the quantum mechanical interaction between the incoming photons and the electron C in the metal. The image in the mirror is constructed from photons that did not exist until the mirror made them. The mirror creates the light you see. It does not reflect it. And your eye does not passively receive that light. Your retina absorbs photons and converts their energy into electrical signals through a quantum mechanical process involving a molecule called retinal, which changes shape when it absorbs a photon, triggering a cascade of protein interactions that generate a nerve impulse. Each photon that enters your eye triggers a discrete quantum event. The image you see is built from millions of these discrete quantum events, each one a probabilistic outcome of the quantum mechanical interaction between a photon and a molecule in your retina, and then your visual cortex takes these millions of discrete signals and constructs from them something it calls an image, a coherent, continuous, three-dimensional perception of a face. This construction is not passive, it is active. Your brain fills in gaps, corrects for lighting conditions, compensates for the blind spot where the optic nerve connects to the retina, adjusts for the fact that you have two eyes at slightly different positions. The image you see is not a recording, it is a model your brain has constructed from incomplete, noisy, probabilistic quantum mechanical data. The face in the mirror is not your face. It is your brain's model of your face, constructed from quantum events in your retina, processed by a visual system shaped by millions of years of evolution to recognize faces, and presented to your consciousness as something that feels immediate, complete, and real. None of those feelings are guaranteed by the physics. All of them are interpretations. All of them are your brain doing something to the raw data, not the raw data speaking for itself. This is the deepest version of the problem. Not that the mirror reverses left and right, it does not, your brain does. Not that you are seeing the past, you are, by 6 nanoseconds. Not that the light is newly generated rather than reflected, it is. But that what you call seeing is itself a construction, a model built by a biological computer from quantum mechanical inputs and presented to you as reality. The gap between the photons arriving at your retina and the experience of seeing a face is enormous. Physics gets you to the retina. Neuroscience takes you part of the way further. But the final step, from neural signals to conscious experience, remains one of the deepest unsolved problems in all of science. I have spent my career solving things, finding the underlying order, deriving the structure from the data. And the question of consciousness, of why there is an experience of seeing rather than just a mechanical processing of photons, is one of the few questions I am genuinely uncertain how to approach. Not because the data is insufficient, because I am not sure the methods of physics, as currently practiced, are the right tools for the question. What I can tell you is this. The face in the mirror is the end point of a chain of events that starts with quantum electrodynamics, passes through the electronic structure of metals, continues through the quantum mechanics of photoreception, and ends in the extraordinary and poorly understood process of conscious visual perception. At every step, something is transformed. At every step, the original signal is processed, filtered, interpreted. By the time it reaches your experience, it has been through so many transformations that calling it a reflection seems almost quaint. The mirror is the least interesting part of the story. The mirror just makes electrons oscillate. The interesting parts are what happens before, in the light, in the photons, in the probability amplitudes, and what happens after, in the retina, in the visual cortex, in the construction of conscious experience. The next time you stand in front of a mirror, think about what is actually happening. Photons from a light source striking your face, absorbed and re-emitted by the atoms of your skin, traveling to a metal surface where they drive millions of electrons into oscillation, those electrons radiating new photons at the reflection angle, those photons traveling to your eye, being absorbed one by retinal molecules in quantum mechanical events, triggering electrical cascades in your nervous system, being assembled by your visual cortex into a model of a face, and being presented to your consciousness as something you call seeing yourself. None of that is you. All of that is a process that ends in a representation of you, a model, a construction, built from quantum events and neural processing and 6 nanoseconds of delay and a front-back reversal your brain interprets as left-right. The face in the mirror has never been your face. It is the face your physics produces, the face your electrons emit, the face your brain constructs, and the real you, the one that exists independently of any observation, any mirror, any photon, any eye, that one you will never see, not because it is hidden, because seeing requires light, and light takes time, and time means the past, and the past is not now. No one has ever seen the present. No one has ever seen themselves. The mirror has been telling you this for your entire life. You just were not listening to the physics.